All right, I think everyone has had a chance to join us by now. Welcome everyone to the Creating Detailed Packed Models Using Lidar in Surfer webinar. Hi, my name is Drew and I'll be your presenter for today's presentation. I'm here to give you the lowdown on how to leverage the Surfer Lidar processing and visualization tools in order to generate point cloud maps and also to post-process Lidar data in order to create 3D surface models in Surfer. It's a very common workflow in Surfer, and we see a lot of our user base execute these tools in order to create these types of maps. So I thought it would be good to give our user base some pro tips on how to approach this workflow and work with Lidar data inside of Surfer. Now, after the discussion of each topic, I'm going to stop for just a few minutes to answer any questions that might have came up. You can send your questions to the webinar host, Brittany, via the questions function at any time. And so you should notice that there is a questions box on the webinar control panel. It's right underneath the audio section. And this is where you can type in your questions and they'll be sent on over to the webinar host, who can then forward it to me to answer. If you notice that your control panel is minimized and you don't see these sections, you can go up to the view menu and uncheck auto hide the control panel, and you'll be able to view the panel in its entirety. Just like all of our other webinars, we're going to be recording. So when we're finished, sometime by the end of the week, we'll have a video available on our support website at support.goldensoftware.com. So if you want to go back and revisit anything that we covered, you should be able to easily do so by going to our support website. All right, so specifically today, I'm going to be walking everyone through the workflow on how to visualize and process Lidar data inside of Surfer using Surfer's Lidar processing and visualization tools. But specifically, I'm going to be focusing today's presentation on creating and viewing point clouds that are going to be created or sourced from LAS and LAZ files inside of Surfer. And we're also going to be filtering using predefined ASPRS classifications inside the Lidar files. We're going to discuss editing point clouds, where we're going to do some selection, cropping, and also reclassifying point clouds using the Reclassify tool. And then also we're going to create 3D surface models from the Lidar data and then take a look at what they look like in Surfer's 3D view window. All right, so there is a ton of information to cover today, so let's just go ahead and get started. Before I get into showing you some examples of how to render and process Lidar data inside of Surfer, I wanted to briefly touch on what Lidar data is for those of you that are not as familiar with this type of data. I'm going to give you some background on this type of geospatial technology. So what is Lidar? Lidar is a remote sensing method that produces massive point cloud data sets, and you'll see that in just a moment, that can be managed, visualized, and analyzed using mapping software, and today we're going to use Surfer. And these point clouds, again, can have millions of data points, so they're quite large and quite heavy files to work with. Lidar is short for light detection and ranging, which this technology uses light in the form of a pulsed laser to measure ranges, or you can consider these distances, to a specified target. A Lidar sensor fires off these laser beams or beams of light and then measures how long it takes for the light to return back to the sensor. Of course, these sensors can be terrestrial or airborne in nature. So Lidar uses laser beams to accurately map out an environment where the mapping and rendering can be done in mapping applications such as Surfer. And this basic mechanism is really known as the time of flight measurement, which again, the laser beam is emitted or shot towards the object. In this case, it's going to be the ground surface. And then reflected off that object or the surface and collected by the sensor which is located within some sort of LiDAR module. And this technology is very, very similar to how radar and sonar function, okay, for those of you that are familiar with that. And then after this data is collected by the LiDAR sensor and module, it is typically processed into an LAS or an LAZ file, and this is really where Surfer comes in. All right, so now that we've covered some basic background for LiDAR, let's go ahead and move on and take a look at some examples so you can see how to work with this type of data directly inside of Surfer. So for this first example, I'm going to start out with creating a point cloud layer, which is the way Surfer renders these types of massive point clouds, or LAS or LAZ files. All right, then you can see now that I have a fresh plot document. And let's start out with importing an LAZ file that I downloaded from the USGS's 3DEP program. Okay? And so I've picked a few LAZ files actually from this area of interest, which is around Red Rocks Amphitheater, which is really close to our main office in Golden, Colorado. All right, so in Surfer, to create the point cloud map, I'm going to go up to the ribbon and click Home, New Map, and in the Specialty dropdown, you can see there's a little arrow here. If I click on the arrow, you can see that I get my specialty map types, and we do have a point cloud layer type. So I'm going to go ahead and click our point cloud. And now we see the open dialog, and I'm going to navigate to the first file that I want to load here. Okay, and this is, again, a USGS 3DEP program LiDAR file in LAZ format. Go ahead and click Open. And again, these are very massive files, so it does take Surfer just a few minutes to load the data and grid it and process it. Okay. All right, so now we see the import points dialog, and this is really the filter command center for LiDAR data when working in Surfer. The very top of the dialog, we have some information about the file itself that we're loading, but what's probably most interesting is this number of points, and you can see that we're working with almost 11 million points to create this point cloud layer. All right, and you see some other items here or settings here in the import points dialog, and we'll get to using some of these classification settings here in just a moment. But for this first import and first point cloud layer, I'm going to go ahead and import the LAS or LAZ file in its entirety. So all 11 points, if you will. All right. So I'm simply going to click OK. And again, give Surfer a second here to think about process the data. There we go. You can see the process indicator. I'm going to bring this layer into focus by fitting it to the plot window. Okay, there we go. We can see the point cloud map or the layer here inside the plot window in Surfer. I'm going to go ahead and select the layer itself in the contents window. And you can see that a point cloud layer is being rendered or viewed by the elevation returns inside the file. Okay. And again, we're using the default color map here, and this map type is merely showing the point locations or the returns, all the returns within this LiDAR file. It is possible to also render by a few other things. We have intensity, which is going to drastically change the look of the file. Right? You can see some of the shadows here. Again, that's light intensity. Return number really brings up a dark map here using this color map. And then we also have, we can view this by the classification value inside the file. Okay, and what's nice to note here, this will come into play later. As you can see, just about all of this is brown, or gray and brown rather, and that's going to be all the ground returns. And then you can see that there's a few strips here that go across from north to south across the map that are being classified as something else. Okay. And these different rendering types can vary, or what the map looks like is going to vary really depending on what's inside the file. So I'm going to go ahead and switch this back to elevation because my goal here is to create a continuous 3D surface from the data. Okay? And so it's a little bit more appropriate to view this or render this by the elevation. All right, so it's always good when you're working with LiDAR data to take a look to see how the point cloud looks in Surfer's 3D view window. Now, I like to do this with all LAS or LAZ files the first time that I create the map, so I can see if there are things like some noise or extra inadvertent data points in the file, or just to make sure that the data is really what I expect it to see. Okay? So I'm going to go ahead and make sure that our map object is selected, and I'm going to go to the View tab in the Properties so I can launch the 3D view. All right, again, we're going to give Surfer just a minute or two here to think and to create our point cloud map. Let's change our point size here just to 0.1 to reduce the way these look inside of our 3D view window, and we can rotate this around. And once I get a nice profile or side view here in the 3D view window, you can definitely see that there is some inadvertent or noise that's associated or in this file, right? Which is probably created by water vapor when the data was collected. Okay. And this is really easily seen if I rotate it around. All right, and so what I'm going to do, I'm going to go back to our main plot window. And I'm going to re-import the data, delete the map, and then re-import the data. But this time I'm going to filter out that noise that we could see floating above the surface in the 3D view. Okay, so I'm just going to delete my map and recreate it. You can select our point cloud type, layer type, select the LAZ file, and click Open. All right, again, we see these the import points dialog, and this is where I'm going to tell Surfer to only import the ground returns. Okay, and this can be easily done by unchecking the classification checkbox, and you can see that all of the classifications that are in the file have been cleared. I'm going to go over and simply check number 2, ground, which tells Surfer to only pull in the ground returns that are classified inside my supporting file. All right, so I'm going to go ahead and create the point cloud layer here. Again, it does take a moment or two here to import nearly 11 million points into Surfer. All right, and so now you should notice here that we don't see, well, it doesn't look like that we can see that noise layer floating above our surface. But again, now that the point cloud has been created, let's go ahead and take a look at the 3D view again, just to ensure that we did filter out that noise, okay, or that it was removed during the import process. And you can see as I rotate the surface or the map, the point cloud layer rather, around, that we have eliminated that extra data. Okay. All right, I'm going to flip back here to the main plot window. All right, so the area here for this example that I want to create the 3D surface from actually extends into another LAZ file, which I've downloaded also from the 3D program. So what I'm going to do now is I'm going to add another point cloud layer to our existing map frame here that you can see on screen using the same steps I did just a minute ago, including only using the ground returns and filtering everything else out. All right, so I can do this simply by making sure my map's selected, okay, by either clicking in the plot window or clicking over in the contents window, and then moving back up to the ribbon and clicking home. And this time in the add to map layer dropdown, I'm going to find the point cloud layer type. Again, navigate to my LAZ file, click open. All right, and we do see the import points dialog again. And let's go ahead and only take those ground returns. Okay. You can see that Surfer is loading the points. Again, now we're going to be working with, over 20 million points inside of this map. Surfer is telling me that the limits need to be expanded. I'm going to go ahead and click yes. And let's fit this to the window so we can see it a little bit better. And now you can see both LiDAR tiles here, or LiDAR point cloud maps have been added. And you can see right here in the middle, there is a direct line, and you can really see where these start and stop. Okay. All right, so now that I've loaded both LAZ files into the same map frame, I'm going to use Surfer's point cloud tools to extract portions of one of the point clouds that I want to use for the 3D surface. So you should notice this southern part, or the southern LAZ point cloud. There's a portion that I'm going to clip out that's going to be right here. Okay, again, using Surfer's LiDAR tools. So the first thing I need to do is make sure that I have the right point cloud selected. Surfer typically loads the new files on the as the bottom layer here, but we can simply toggle it on and off. And sure enough, I do have that selected correctly. All right, and so you should notice once I have the point cloud selected that my commands up in the ribbon have changed. Okay, and so when this point cloud layer is selected, the ribbon gives me some context sensitive options here, or commands, and Surfer exposes all the LiDAR processing tools. Okay, you can see those all right here. All right, so now to extract this portion right here of the bottom LiDAR point cloud, I'm going to go up to the ribbon and click point cloud, point selection, and use the rectangle tool. Okay. So I click it, you can see my mouse pointer has changed, and this means that I'm in some sort of drawing or editing mode. And I can simply drag a box around the points that I want to select. So you can see like that, I'm just dragging a rectangle here. Right, and you can see now that this portion of this point cloud layer has been selected. All right, so now that they're selected, I'm going to move back up to the ribbon and click point cloud, modify, and I'm going to use the crop to selection tool, which is going to go ahead and clip or crop out those points that are not selected. Okay. And you can see right here that these points are now gone. And what I'm going to do now is I'm going to use the deselect all command to get that selection tool off. All right, and you can see now that I have two point cloud maps that I'm going to be using to create our 3D surface. All right, so Now that I've extracted just that top portion of the southern point cloud, I'm going to go ahead and export the point cloud layer to a new LAZ file, okay, by simply going back up to the ribbon and clicking Point Cloud, Features, and Export LAS or LAZ. Again, this is going to create a new LAS or LAZ file. All right, so I'm going to click the Change File Name. I'm going to add clipped here to the end of my file name, so I know that it's different from my original. And go ahead and click OK. And Surfer does create or exports the LAZ file pretty quickly. You saw that. All right, and so now what I can do is I can take both of my LAZ files, now that we've post-processed one, and grid both of them, mosaic them together, and then we can create a 3D surface from that resulting grid file. Okay, so this can be easily done by going up to the ribbon. I'm going to click Grids, New Grid, Grid Data, and we see the Grid Data dialog. Okay. So the first thing I need to do is browse and pick my my first LiDAR file. Okay, and I click Open. Give Surfer just a second to think. And so the next thing that we see here is the LiDAR import filtering dialog. And again, we do see a nice classification set of controls down here at the very bottom to do some filtering. And for the 3D surface or the grid file, it would make sense to only use the ground return. So I'm going to simply click this Clear All button, check the ground returns here. So I only pull those points in, and then go ahead and click OK. All right, so now the data has been loaded into the grid data dialog. And since Kriging already creates some real nice smooth surfaces, I'm going to go ahead and leave that set to for our gridding method. And at the bottom of the dialog, I'm going to click the Skip to End button. All right, so on this last page here of the grid dialog, grid data dialog rather, I'm going to set the spacing to be a little bit higher resolution here, so we can get some pretty good detail in the surface from these LiDAR files. Now, I know I'm working in meters here, so my spacing is approximately 4, as you can see. That means I'm creating a 4-meter resolution grid file. Now, we could always do meter or sub-meter here, but for the sake of time and processing time, I'm going to leave these set to about 4 meters. But I do think that's going to give us enough resolution that we can see enough detail in the resulting surfaces. All right, and so at the bottom here, I'm going to choose to add the grid to our existing map frame, and I'm going to use a color relief layer. All right, so now that I have everything set in the grid data dialog, I'm going to go ahead and click Finish. And let Surfer grid the data. And one thing to note here is Surfer is doing this really quickly. You can imagine how long it takes to grid almost 11 million points. I'm going to save the spatial referencing, click OK. And we should notice here, let's zoom out just a little bit. If I turn my point cloud layer off here on the top, that we do have a nice surface created. So I'm going to go ahead and repeat these steps and grid the other set of LiDAR data where I extracted only this top portion for. Again, back in the ribbon, grids, new grid, grid data. I'm going to browse to get my file. Okay. And this was the one that we clipped. Again, I'm going to clear our filtering and only use those ground returns to ensure we're just looking at the ground data. We can stick with kriging. And again, I'm going to change that resolution a little bit by changing my spacing parameter down to 4. And choose to do the same thing here. Add our new layer that we're creating as a color relief layer to the existing map frame. All right, everything looks good to go. Let's go ahead and create the grid file. All right, same thing. If I turn off our point cloud layer, you should see now that we have some nice detailed looking grid files and color relief maps here. If I zoom in, still you can see that this does have a little line here, and you can see where the two files are touching. And so let's go ahead and mosaic these two grid files together so we can create one continuous surface. All right, so we can easily do that by going to the grids ribbon tab, going over the resize section and clicking mosaic. In the open grids dialog, I'm going to select my first grid file and click open. You can see the extent here, and also our geometry settings. I'm going to add our next one. Right, you can see the extents here. I'm going to rename the grid file to be combined here so I know what we're looking at. And of course, we want to add this to the existing map frame, and let's stick with the color relief layer. Okay, I'm going to go ahead and click OK and mosaic both of these grid files together. And then again, we can see that we've added a new layer here. And once I turn everything off, you can see that we've got a nice continuous surface that we've created from the LiDAR data. Okay. For this particular surface, I'm going to change our color mapping here to grayscale. Make sure I have the right layer selected. I want to lighten it up just a little bit, so I'm going to go white to light gray. Okay. Now, to finish this model up, I think it would be proper to download some imagery, maybe a nape image, and overlay it or drape it across the surface. And then we'll take a look to see what this looks in the 3D view window. So making sure my map is selected, I'm going to go to the Add to Map section and Layer dropdown. I'm going to use the Base from Server command. All right, now we see that Download Online Maps dialog. I'm going to expand the nape server. Pick the correct layer here, which is going to be that USGS nape imagery. And you can see a nice preview here of that image. Let's increase the resolution here just a little bit. 41 meg should probably do it. Of course, if I was doing this for a project, I'd probably download a higher resolution image. But for the sake of time, I'm going to keep it at about 40 megs here. Again, let's give Surfer just a moment here to think and get that image from the nape server. All right, so it's added to the map. And you can't really see it because it's on the bottom here. So I'm going to reorder the drawing order. And you can see that we've got a nice detailed high resolution image overlaying our surface. And then now I'm going to tab over to our 3D view window and take a look at the surface model that we've created here from the LAS and LAZ files, or the LAZ files rather, gridding it, and then overlaying the nape image. You can see that we've got a great looking model, and this would be a great starting point for any project to be built upon. All right, so I'm going to open it up for any questions that might have came up during this first example. So if you have any questions, please feel free to send those on over to our webinar host, Brittany, so she can forward them to me so I can get them answered. All right, so it looks like I have a couple questions about the data. So the first question here is, what is the difference between LAZ and LAS files? Okay, I know you heard me mention that a few times. LAZ is just a zipped version of the LAS, and typically it'll be a little smaller in file size. Okay, and so they both function the same way. One's just a zip version of the other. All right, and so another question, where did you get this data, and was it free? And that's a great question. Everything that I used to create this project, the surface model was downloaded for free. I used a nape image, which is free for, I think, just about the entire United States. And then the LiDAR data, more importantly, was downloaded from the USGS 3DEP program. And again, that's free, and the US tax dollars pay for that. So this is a really good source of getting LiDAR data that's been somewhat processed and will work really well inside of Surfer. Looks like I have time for a couple more questions. One of the questions is, how do I export the final model to JPEG, PSD, or PDF? PSD is not supported. In the current version of Surfer, in this 3D view window, we can export an image, which is going to be a snapshot, right? By clicking this export image, right? And we have a few different bitmap or image, raster image formats. You can see those listed here. And what's really cool, we are going to be releasing a new version of Surfer in the first part of September. That will include, I believe it's in this version, or it might be in the beta version for those of you that are in active maintenance. We will have a 3D PDF option that's going to be found right here. And so I think that's really exciting. Please look for that in the upcoming version. Yes, okay, so Brittany's telling me it's in the beta version and in 19. So take a look at that upcoming here in September. And for those of you that want to run that new version, I think that's an excellent added piece of functionality. Please make sure you have your maintenance renewed. One last question, can you crop a section from the 2 LAS files? And that's a great question. I'm going to tab back and then also turn off our image here and turn the point cloud layers on. And the answer to your question is no. However, or this is why, when the point cloud layer is selected, these context-sensitive tools become available, and they're only available to be working on the selected layer. So let's say if I wanted to use a part from the top and a part from the bottom, I would have had to do 2 separate crop and selections and crop. So, all right, so thank you very much for the questions, everyone. Those are great questions. If there were any unanswered questions here towards the end of the presentation, I'll try to do my best to get them answered, of course, time permitting. All right, for the second example and final portion of today's presentation, I'm going to show you another example of using similar LiDAR data in Surfer to create a detailed model again, which I downloaded this next set of files from the 3DEP program as well, which are going to contain a section of the Golden Gate Bridge in San Francisco and the surrounding park area. All right, so the first thing I'm going to do here in the blank plot window is to create a point cloud layer for my file. Okay, and I'm going to use a similar approach to the first example, but this time after creating the point cloud, I'm going to use these selection tools to select that Golden Gate Bridge, reclassify the points, and then create a new LAZ file. Okay, so let's go ahead and again, I'm going to create my point cloud layer here. All right, select my LAZ file and click open. I'm going to go ahead and import, and you can see how many points are in this file. 15 million, a little bit more. So of course, we're going to have to give Surfer just a second here to think and import these points. All right, there it goes. You can see the progress indicator. All right, let's bring this into focus. All right, and you can see here that we have what looks to be the bridge. This is the Golden Gate Bridge, and then the park that's right there on the edge. Well, let's go ahead and take a look again in the 3D view. Make these points just a little bit smaller. And then rotate it around with the trackball. Zoom in a little bit here so we can see them. Most of this area is actually water, as you can imagine. But you can clearly see, now we have the Golden Gate Bridge here extending. You can see the supports. If I pan down a little bit more here, you can see in this area that we definitely have that landing area or that park that's right to the edge of the bridge. Okay. All right, so I'm going to go ahead and access back in the plot window. So I'm going to access the Lidar point cloud tools, again, by first selecting our point cloud layer here in the contents window, and then moving back up to the ribbon, and you can see our tools are now available. Okay, so the polygon point selection tool is going to work really well to select the bridge. So I'm going to go up to the ribbon and click point cloud, point selection, and this time I'm going to use the polygon tool. And I'm simply going to zoom in just a little bit, and I'm going to click around here and do my best to select as much of this bridge as I can. Okay, you can see I'm just clicking around. When I get to the end, I'm going to double click. Okay. All right, now I can see that the bridge has now been isolated or selected in the Lidar file. And I know that from experience here working with this file, that these bridge points are actually unclassified. So we can reclassify these by going up to the point cloud, classify, and in the classify dropdown, I'm actually going to classify these as a building. Okay, so you can set reclassify to building. All right. Then I'm going to remove my selection or turn that selection tool off by clicking that deselect all. Okay. And you can see now that we have all the points back, but everything that I had selected before are now going to be deemed as buildings. All right. So you can see there's quite a vast area here to the east of the bridge that I want to go ahead and remove from our Lidar file or crop it out. All right, so I'm going to go up to the point selection and this time use the rectangle tool. Let me just draw a box here all the way around these points. You can see that they're selected. And this time I'm going to go use the point cloud to modify, remove the selected points. I'm going to just take those out. Okay. And then deselect all so we get all of our points back. Right? And so we can see we have a smaller strip of data to work with now. All right, so I'm going to go ahead and export the points out to another LAZ file so we have a smaller file to work with. Okay, and this can be done again by going to Point Cloud Features, Export LAS LAZ. I'm just going to put cropped at the back, and we're going to export an LAZ file. Okay, let's give server just a second here to actually create the LAZ. All right. All right, so now that we've exported this, I'm going to go ahead and create a new plot. And we're going to first I'm going to create a ground surface here by only gridding the ground returns, okay, for that file that we just exported. Right, so I can click grids, new grid, grid data. I'm going to browse, select my LAZ file that I just created and click open. All right. Again, we want to clear all and use only the ground returns. Okay. Again, I think Krieging for the gridding method is going to be a good selection here. I'm going to skip to the end. Make these a little higher resolution here. And I'm going to choose to create a new map. And this time, let's create a contour map from it. So I'm going to go ahead and click Finish. Let Surfer grid that data and create the map for us. Okay. And I'm going to fit this to the window. So you might notice here that this is that long strip. That's because only that top portion in the LAZ file contained those ground returns. And one thing that I really don't like about this map, you can see out here that there are a little bit of strange gridding artifacts, if you will, that was created while gridding the file. And so we can take a polygon boundary and assign node data to these areas. And for the sake of saving time, I've already created that polygon boundary file to assign node data with. So let's go ahead and add that into our map as a base layer. Right. And you can see our polygon boundary here. I'll make this a little bit more apparent here, more easier to see. Right. You can see this is our polygon here. Right, that area right there. Okay. Now I'm going to go ahead and assign node data. Okay, a lot of you should be familiar with this by going to the ribbon and clicking grids, edit, assign node data. In the assign node data to grid dialog, first I'm going to select my cropped grid file. Next, for the node data polygon boundary, I'm going to select the base layer we just added. We want Surfer to assign node data inside of this polygon boundary. And we're going to choose to add a color relief layer to our existing map frame. Okay. I'm going to turn our contours off. You can see our surface here. And in the color relief layer, I'm going to turn this black node data area on to be 100% transparent, okay, by setting that opacity to 0. Going to turn off our node data polygon because we don't need that. All right, so the next thing I want to do, let's add a little bit of detail here by using that same nape server. Okay, so the same exact steps as I did earlier. There it is. I'm actually going to cancel that out. It's because I don't have my coordinate system set. So this is UTM 10 north, NAD 83. So we can go ahead and change this. NAD 83 10 north, it's right here. Go ahead and click OK. There's a few layers that don't have anything set, so I'm going to assign those now. Just to verify. Okay. So now we can add our layer from the base layer from the server. There we go. Should be a little bit better. There we go. And again, I'm going to use a higher resolution image here. Go ahead and add that to our map. You should see here, we can see some of the stuff underneath, but I'm going to bring my layer to the top. All right. And let's go ahead and launch that 3D view window so we can take a look here. All right, so you can see now that we've got a really good looking ground surface model, okay, with the image draped over the top. And the last thing I want to do here for this example is add that bridge in, okay? So I'm going to go back to our plot window, and we can add another point cloud layer from that LAZ file that we reclassified just a moment ago, okay? Point cloud. But this time I'm going to only bring in that building return or the classification. All right. So I'm scroll down in the classification. Looks like I went a little bit too far. And there we go, building. Click OK. All right, just give Surfer a moment here to process. I'm going to tell Surfer it's okay to expand the limits. And I'm going to bring this into focus like I've done with the other maps. You can see our bridge here is extended. I'm going to bring this up here to the top. And then let's click back over to our 3D view. Points look a little bit bulky here. Again, I'm going to change these to 0.1. Okay. And then also I'm going to click on the environment contents object and add our water level. 3. And as I zoom in, you can see the structure of that Golden Gate Bridge and also our surface model here that we created from gridding that data. Right, again, this is a really good example of how to create a surface model that you could use then to build upon. All right. All right, so I'm going to go ahead and open it back up for any questions that may have come up. either from that first example or this second example. And so if you have any questions, please feel free to send those on over to Brittany. Okay. We do have just a few extra minutes here before the end of the hour. So if you have any questions, again, please feel free to send those on over to Brittany. All right, she's telling me there's not any unanswered questions. All right, so that concludes my presentation of the creating detailed packed models using Surfer, using Lidar and Surfer. Hope everyone found the information that I covered helpful and useful for their workflows. If you have any additional questions on what was covered today or anything else Surfer related, now that we're concluding the webinar, please send your questions to support@goldensoftware.com. And again, we're going to be posting a recording of today's webinar by the end of the week on our support website, which is support.goldensoftware.com. And on behalf of Brittany and myself and of Golden Software, we thank you very much for your time and have a great afternoon.